Okay, subtracting fractions. Subtracting fractions is essentially exactly the same as adding fractions until we get to something that looks like this. We're going to talk about that in a minute. But firstly, we're going to have a look at these ones, and we're just going to quickly go over the sort of things that you might encounter and a revision on how to add fractions. So, if you can remember, when we add fractions together, the only rule was you have to have your denominators the same. The same thing applies here, okay? We must have the same denominators. So our very first step is to turn our denominators into common denominators. And remember, we always look to see if I can turn the little one into the big one. In this instance, I can't. So I'm just going to multiply them together. So 5 times 3 gives me 15. So we're going to have a denominator of 15. Obviously, what did I multiply 5 by to make 15? I multiplied it by 3. So I have to do the same thing to the top. And once again over here, I multiplied 3 by 5 in order to make 15. So I need to multiply the top by 5 as well. So we end up with 12 over 15 and 5 over 15. And now we can perform our subtraction. So 12 take 5 gives me 7 over 15. And that's my answer. Over here, once again, can I turn a 7 into a 9? No, I can't. So I need to multiply this side by 7 and then this side by 9, okay? 6 times 7 gives me 42, okay? And 9 times 7 gives me 63, okay? Over here, 2 times 9 is 18, and obviously both of our denominators are the same. So now I can do my subtraction. 42 take 18 gives me 24. And 24 over 63, we need to see if we can simplify that. And the answer is that we can simplify this. And the reason why I was able to see that straight away is I quickly referred back to my divisibility rules. And my divisibility rules for 3, the number 3, is if I add the digits up and I can divide them by 3, it means that we can divide the number by 3. So 2 plus 4 gives me 6, and I can divide 6 by 3. 6 plus 3 gives me 9. I can divide that by 3. So I can divide this fraction by 3. So 3 goes into 24 8 times, okay? And it goes into 63 21 times. And now we have a simplified fraction there. However, with this one, this is where subtracting fractions changes a little bit. Because what we have here, we have a situation, I'm going to show you in a minute. We're going to, first of all, find our common denominators. So can I turn a 3 into a 6? Yes, I can. I can turn a 3 into a 6. I have to multiply it by 2. Whatever I do at the bottom, I have to do the top. So let's perform that operation. And I end up with 2 over 6 minus 5 over 6. Now, can you spot the problem here with these two fractions compared to those ones? And the answer is that in these ones, this fraction, okay, this fraction has always been bigger than the one that we take away. In this instance, it is smaller, okay? So what we're going to have to do is we're going to have to borrow. Okay, we're going to have to borrow from the 1. Now, if I have a subtraction, a normal subtraction algorithm, and I've got something like 204 take away, let's say 87, okay? When I have something like that, and I do 7 take 4, and I go, ugh, I can't, sorry, I do 4 take away 7. I go, oh, I can't do that. I need to borrow. You need to borrow. So we borrow all the way over here from the 2, and then I have a 9 there, and then I have a 10 here. And then I go, okay, well, I can do that now. I can do 14 take 7, which gives me 7, and 9 take 8, which leaves me with 1, and my answer is 117. Now, here we do a very similar thing. I'm essentially borrowing because with this fraction, I don't have enough numerators to take away the numerators over here. So I need to borrow from this 1. Now, in every single whole number, we have 6 parts. So I'm going to consume that 1 whole that I've got there, and I'm going to have 8 over 6 now. Take away 5 over 6, okay? And now we can see that our fraction on the left is actually bigger than the one on the right. So I can perform the subtraction. So 8 take 5 gives me 3 over 6, and then obviously that equals 1/2. So subtracting fractions is basically always the same as when you add fractions. The only change is when your first fraction is smaller than your second fraction and you need to borrow from whole numbers, okay? Now, if this whole number was, let's say, 10, okay, and I'd still have 10 here, but then here I needed to borrow, I can just borrow 1. I can keep 9 there, okay? I can keep 9 there. And you could also have a situation where you're also taking away 2 and 5, 6, okay? And in that situation, we borrowed 1 from our whole numbers on this side to leave us with 9, okay? 9 and 8 over 6. And here on this next step, we would just do 9 take 2, which leaves me with 7 and 7.5 as our answer, okay? So when you have whole numbers, sometimes you need to borrow from them, okay, in order to complete your subtraction. But everything else is exactly the same as adding fractions.